In this lecture, we'll talk about the concept of a multiplicity of a zero of a polynomial. So, just to review the terminology, a zero of a function f of x is a solution to the equation f of x equals 0. So this should be familiar to you. This is the same way you find the x-intercepts, and in fact, the word 0 of a function, that term, is just another way to say the x-intercepts of a function. So the x-intercepts are zeros and vice versa. But a lot of times, with the concept of multiplicities, you'll talk about the multiplicity of a zero, and what that means is the multiplicity of a zero of the function. In other words, the multiplicity of an x-intercept. Okay. So, for a polynomial, every zero has a multiplicity associated to it, which is a number that comes associated to that zero. And I'll explain where that comes from up here. So here's an example of a polynomial. X plus 1 squared times x minus 2 times x minus 5 cubed. And now, in this chart, we have the zeros of the polynomial on the left. You can see that these are zeros by looking at each term. Negative 1 is a zero because of this term up here. Right, when you plug in negative 1, you have negative 1 plus 1, which would become 0. And then when you multiply this stuff by 0, the entire polynomial becomes 0. So anytime a polynomial is factored like this, it's very easy to find the zeros. You just make each individual term equal to 0. So now, if we go further on, we see x minus 2. So 2 will be a 0 of this function. And 5 will also be a 0 of the function. Now, to find the multiplicity associated to a 0, you look where it came from in the polynomial. In other words, you look at the term in the polynomial that made negative 1 in this case a 0. So negative 1 corresponds to x plus 1, because when you plug it in here, it makes this individual term 0. So these, negative 1 and x plus 1, are sort of associated to one another. They're paired together. And the way you find the multiplicity is you look at the exponent. So in this case, the 0, negative 1, has a multiplicity of 2, because that is the exponent on x plus 1. Right, and x plus 1 goes with negative 1, because negative 1 plugged into here makes this 0. Okay. So now how do we find the multiplicity of 2, for example? Well, we go to the corresponding factor in the polynomial, x minus 2. And to find the multiplicity, we look at the exponent of that factor, which is 1 in this case. So it has a multiplicity of 1. And finally, 5 is 0. If we go up to the polynomial, to the factor that corresponds to it, x minus 5, we see that the exponent here is 3, so the multiplicity is 3. Now, the reason we're learning about these multiplicities is because they'll help us to graph polynomials later. But for now, we'll just focus on the concept of multiplicity. So here's another example. Q of x equals x to the 5th plus 2x to the 4th plus x cubed. Now, if we want to find the zeros of this, we should factor it first. So we factor it completely. See, we can factor an x cubed out of everything, bring it to the outside. And now in here we have a quadratic, and we can factor this as x plus 1 squared. So we have x cubed times x plus 1 squared. And in this form, it's very easy to read off the zeros and to find their multiplicities. If we just looked at it this way, it would be hard to find the zeros, and we would be unable to find the multiplicities even if we could find the zeros. So once we have it in this form, we can read off the zeros. X equals 0 corresponds to this term, because if you plug in 0, x will just become 0, and when you multiply it by this, the entire polynomial would become 0. And now from this term we get that negative 1 is a 0 of the function, because when you plug in negative 1 here, the entire thing would become 0. Okay, now what are the multiplicities associated to them? Well, 0 comes from the term x cubed, and the exponent there is 3, so 0 has a multiplicity of 3. Negative 1 comes from this term, x plus 1, which has an exponent of 2, so the multiplicity of negative 1 is 2.